Hi everyone, we're going to do this question from the OneNote. It's a question out of the book using a spreadsheet to find the line of best fit. It's called the least square regression line. It's just a fancy name. It's a particular method. We don't get into that. So I've taken the liberty to put the data in here. Time, population born in the UK. So again, to do the plot, we ignore the years. Those have been represented by 0 to 40. So basically 0 represents the start of the data, 1971. How many years after 71? Well, 40 years after is 2011. So that's how we do that. So go to Insert. We're going to get a chart, which is a scatter plot. Nice and helpful there. We're going to change a couple of things about it. First thing, I'm going to change the title. Population born in UK and Ireland. I'm going to change that to over time so that it's kind of clear. Now, if I click on the graph, this plus sign comes up. So if I press plus, it may be different on Macs. You might need to go up here to add chart element. I can do a couple of things. I'm going to add axis titles just so we're clear. So we're going to do, this one is percentage of population. And the horizontal one is time or years since 1971, not 2971, 1971. Okay, we're going to add a trend line. Here's how you do it. You go to the plus, go to trend line. You can click that box, but I want to show what the equation is. So we're going to click that and go more options. We've got a linear trend line, not an exponential, other things like that. We want linear, and it's very clearly linear, by the way. And so we've got that. We are going to display the equation on the chart, and why not? We're just, for the sake of it, I'm going to also put the R value. That's the correlation coefficient. So now I've put both of those. I can close this. I'm going to move them so I can see it a bit more clearly. And so you see a couple of things. We've got a very high correlation coefficient, 0.98. If you square root that, I mean, it's very high, almost 1. It's a very strong, very strong correlation here between the two things. As time has passed, the population has steadily declined. So basically, y is equal to negative 0.08 plus x, 0.08x plus 8.532. So the negative 0.08 is my gradient, and the 8.5 is my y-intercept. That's how we do it. So we give an answer the first two parts. And to interpret, the question says, interpret the gradient and vertical intercept in the context of the data. Well, basically, in the context of the data, the gradient tells me the rate at which the population is decreasing. Or if it was a positive gradient, it would be increasing. But this is telling me how it's decreasing. It's at a rate of negative 0.08, right? Based on the years, and you could work that out as a percentage per year, et cetera, on average. But basically, in simple terms, the gradient tells us there's a steady decline as the years go by. It's a negative value. The y-intercept, the 8.532, is telling us, well, where it crosses this vertical axis. But it's also telling us, in this case, where we're starting from. What was the percentage of the population born in the UK and Ireland in 1971? Basically, that's where we start. And then it's just steadily decreased. So that's how I would interpret. I'll write a couple of things in the OneNote. And so let's see how we go. Okay.